So here 3 can divides 12 and 3 can divides 24, 3 can divides 48. Have written the relations. Can divides 2, 1 can divides 3, 1 can divides 5 and 1 can divides 7. 2 can divides 4, 8, 16, 32 and 2 can divides 4 and 4 can divides 8 and 8 can divides 16. Hello everyone, welcome back to my new session. In my last session, I have discussed about Hasse diagram and maximal element and minimal element. So today I will discuss another problems on Hasse diagrams. I will explain the problems on Hasse diagram and how to find the maximal element and minimal element in Hasse diagram. So definitely you can expect this question for 7 marks. So first question, draw a Hasse diagram for 3, 4, 12, 24, 48 and 72 and it is divisible. So first you have to find the relations according to the divisibility. So here 3 can divides 12 and 3 can divides 24, 3 can divides 48. Have written the relations and 3 can divides 72 and 4 can divides 12 and 24, 48 and 72. And next element is 12. 12 can divides 24 and 48 and 72. And the next element is 24. 24 can divides 48. 24 can divides 72. So now I will draw a Hasse diagram. Here you just observe this relation. You have to remove the self loop. Self loop is not there. And you have to remove the transitivity. So directly by seeing this set of elements, you can draw a Hasse diagram, right? So I will draw a Hasse diagram for this. 3 is a least element. The first element is 3 and the next element is 4. 3 can't divides 4, right? 3 cannot divide 4. So next element is 12. 3 can divides 12 and 4 can also divides 12, right? So 3 is the first element and 4 is the second element. 3 cannot divide this 4. And the next element is 12. 3 can divide 12, 4 can also divide 12. And the next element is 24. 12 can divides 24. Is it right? Yes, it can divides 24. And the next element is 48 and 72. 24 can divides 48 and 24 can divides 72. This is your Hasse diagram for the given pose set. It is very simple. Please understand the concept. So first element is 3, the second element is 4. So 3 cannot divide this 4. So I will separate the elements 3 and 4 and 12. 3 can divide 12, 4 can also divide 12. And the next element is 24. 12 can divide 24, right? And the next element is 48. 24 can divide 48, 24 can divide 72. It is very simple. First write the relation. By seeing this, you can draw a Hasse diagram directly. In examination, sometimes you will get to find the maximal value and the minimal value in Hasse diagram. So here, how will you find the maximal value? Maximal values are the values which is not related to any other values. That is 3 and 4 and 48, 72 is a maximal value. It is not related to any other value and 12 is a minimal value. So this is your Hasse diagram and maximal value and the minimal value in Hasse diagram. And the next problem we have, draw a Hasse diagram for A is equal to 1, 2, 3, 4, 5, 6, 7, 8. Find its maxima and minimal elements. So how to draw a Hasse diagram for this? So here the first element is 1 is the least element and 1 can divide 2 and 3 and it can divide 5 and 7 also, because here 2 can divide 4 and 2 can divide 6 also. So here I have written only 2, 3, 5 and 7. 1 can divide 2, 1 can divide 3, 1 can divide 5 and 1 can divide 7. So now the next element is 4. 2 can divide 4 and the next element is 6. 2 can divide 6, 3 can also divide 6. And the next element is 8. 7 has done. The next element is 8. So 4 can divide 8. This is your Hasse diagram. It is very simple. Listen carefully. So 1 is the least element. The first element is 1. 1 can divide 2 and 3. And it can also divide 4, 5, 6, 7. But here instead of writing 4, 5, 6, 7, 8, I'll write only 5 and 7. So 1 can divide 2, 3, 5, 7, 4, 6, 8 also. But 2 can divide 4, right? So directly I will write it in the next step. So it should be in a upward direction. 2 is a lesser than 4, right? So 2 can divide 4. And next element is 6. 2 can divide 6. 3 can also divide 6. So I'll write it in a upper direction. And the next last element is 8. This 4 can divide 8. So this is your Hasse diagram for the given POSIT values. So now how to find the maximal and minimal value for the given asset. So now we have to find the maximal and minimal element also. So minimal element is 1. It is minimal element. And the maximal element is 8. It is not related to any other value. 6, 5 and 7. 3 is not a maximal value because 3 is related to 6. 2 is related to 6. 1 is related to 2, but 2 is not related to 1. So minimal value is 1 and the maximal values are 8. It is not related to any other value and 6 is not related to any other value and 5 and 7 is a maximal value. So maximal elements are 8, 6, 5 and 7. And the minimal elements are 1. Is the minimal elements. So like this you have to find the Hasse diagram with maximal element and minimal element if it is 7 marks. And the next question we have POSIT A equals 2, 4, 6, 12, 24 and 36. So here you have to draw a Hasse diagram. So I will draw a Hasse diagram for this. So first element is 2 and the next element is 4. So 2 can divide 4, right? So I will write 2 can divide 4 and the next element is 6. 2 can also divide 6, right? And the next element is 12. 4 can divide 12, 6 can also divide 12. So 4 can divide 12 and 6 can also divide 12, right? I have connected here 4 to 12 and 6 to 12 also. Now, the next element is 24. 12 can divide 24 and 12 can divide 36 also. So I will connect 12 to 24 and 12 to 36. So here 12 can divide 24 and also 36. So I will repeat 2, 4, 6. So 2 is the first value. 2 can divide 4 and 2 can divide 6. And the next element is 12. 4 can divide 12, 6 can divide 12 also. So I have connected here. And the next element is 24. So 12 can divide 24, 12 can divide 36. So this is your Hasse diagram. So now find out the maximal and minimal value. The minimal value is 2. Minimal value is 2. Minimal element is 2. And the maximal elements are 24 and 36 because it is not related to any other values. So maximal values are 24 and 36. This is called as Hasse diagram and here we got the maximum value and minimal value also. And the next problem, A is equal to 1, 2, 3, 6, 12 and 24. So 1 can divide 2, 3, 6, 12 and 24, right? First you can write the relations and you can draw a Hasse diagram, and you can also find the maximal value and minimal value. So first I will write the lowest value. First value is 1, and 1 can divide 2 and 1 can divide 3. Is it right? And the next element is 6. 2 can divide 6, 3 can also divide 6, right? And the next element is 12. 6 can divide 12, and the last element is 24. 12 can divide 24. This is your Hasse diagram for a given 4 sets. 1 can divide 2, 1 can divide 3. So 1 can also divide 6, but have removed the transitivity, self-loop and asymmetric property, then I can directly draw a Hasse diagram. So 1 can divide 2, 1 can divide 3 and 2 can divide 6. The next element is 6, 2 can divide 6, 3 can also divide 6. And the next element is 12, 6 can divide 12 and 12 can divide 24. This is your Hasse diagram. So now find out the maximum value and minimum element. Obviously the minimal element is 1. Minimal element is 1 and the maximal element is 24. Maximal element is 24 because it is not related to any other value, right? So here we got the value of maximal element and minimal element. And the next problem is A is equal to 1, 2, 4, 8, 6, 32 and 64. So here you have to find the Hasse diagram and also you can find the minimal and maximal element. Here first I will find the relation R equals 1 can divide 1 and 1 can divide 2 and 1 divides 4, 1 divides 8, 1 16, 1 divides 32, 1 divides 64. The first step. And the next step is, the next element is 2. 2 can divide 2 and 2 can divide 4, 8, 16, 32 and 2 can divide 64. And the next element is 4. 4 can divide 4 and 8. 4 divides 16. 4 divides 32 and 4 can divide 64. And the next element is 8. 8 can divide 8 and can divide 16 and 32 and 64. And the next value is 16. 16 can divide 16 and it can divide 32 and 64. And the next element is 32. 32 can divide 32 and it can divide 64 also. And the last value is 64. 64 can divide 64. So this is your relation. So using this relation you can draw a Hasse diagram. So what is the first procedure to draw a Hasse diagram? You have to remove the self loop. So I will remove this self loop. 1, 1, 2, 2, 4, 4, 8, 8, 16, 16, 32, 32 and 64, 64. First procedure is we have to remove the self loop because it is reflexive property. So A, A belongs to R 1, 1 belongs to R. So it is reflexive property, right? So first procedure is we have to remove the self loop in a digraph. And the next procedure is remove transitivity. Transitivity. So what is transitivity? Example 1 to 2 and 2 to 3. 1 belongs to 2, 2 belongs to 3, 1 can also belongs to 3. So for this given set of elements, I can consider 1, 2 and 4. 1 belongs to 2, 2 belongs to 4, 1 belongs to 4. So I can remove this 1, 4. And again 1, 2, 8. 1 belongs to 2, 2 belongs to 8. 1 can also belongs to 8. So I can delete this 1, 8. So using this method, you can delete the transitivity. So this is your next procedure. First, you have to remove the self loop, and the next step is remove all the transitivity. So in the next step, you can draw a Hasse diagram. So now, I will draw a Hasse diagram for this. 1, 2, 4. So first element is 1. Least element is 1. And here you can observe the numbers 2, 4, 8, 16, 32 and 64. All the values are divisors of 2, right? So I can divide all these numbers by 2. So first element is 1. You just observe the values 1, 2, 4, 8, 16, 32 and 64. All the values can divide by 2. So first value is 1. 1 can divide 2 and 2 can divide 4 and 4 can divide 8 and 8 can divide 16. 16 can divide 32 and 32 can divide 64. So this is your Hasse diagram for the given pose sets. You just observe the set of elements properly. So then easily you can draw a Hasse diagram. So without using the relation also, you can draw a Hasse diagram. If you want, you can prepare the relation first and remove all the self loop and transitivity. And after that, you can draw a Hasse diagram. If it is 7 marks or 8 marks question, please write all the relations first and you can draw a Hasse diagram and maximal value, and also you can find the minimal element. So here the minimal element is 1. And the maximal element is 64. This is your maximal element because it is not related to any other elements, and this is minimal element. This is for 7 marks question. Easily you can score on this topic. Please practice the problems and understand the concept properly. So it is partial orders, Hasse diagram and elements of pose set. Pose set in the sense partial order set. We have two methods in pose set, that is maximal element and minimal element. So with the help of this Hasse diagram, we can find the maximal element and minimal element in Hasse diagram. So this is your partial orders on relations. I will give one assignment problem. Please practice the assignment problem. Set A equals 2, 3, 4, 5, 6, 30 and 60. So it is your pose set value. You just find the relations like this and draw a Hasse diagram and also find maximal and minimal element. So this is a given pose set values 2, 3, 4, 5, 6, 30 and 60. Just find the relation values and draw a Hasse diagram, and also you can find the maximal and minimal value to this problem. Please practice this problem. This is your assignment question. My dear students, please practice all the problems. Easily you can score 100 out of 100 in discrete transformation. It is very simple and easiest subject in first semester. It is a scoring subject in first semester B.C.A. And I will give one more question. Please practice this question also. Set A equals 1, 2, 3, 5, 11 and 13. Second question. This is your first question, assignment question. And the second question 1, 2, 3, 5, 11 and 13. So here first find the relations and draw a Hasse diagram and find out the maximum and minimal element. So my dear students, with this we have end of this unit 1. Have covered all the problems in first unit. Please practice all the problems. If you missed my classes, please follow the link below and subscribe to our YouTube channel, and you can watch all the session videos. So today you learned the problems on Hasse diagram, and also you learned the concepts of maximal element and minimal element in Hasse diagram, right? So I have given the assignment question also. Please practice this question and this question also. Find the Hasse diagram and maximal and minimal value. In my next session, I will come with a second unit in discrete transformation. Thank you.